Yeah. Okay, so hello everyone. I'm gonna talk about, well, JavaScript modules, past, present, and future. So where are we now, why we're here, and what we can expect in the next 5, 10 years maybe? Well, I've never been introduced. I'm Nicolo. I'm not going to repeat that. And so let's get started. Most talks are about like new exciting features. So let's do something different, and let's start from many years ago. Once upon a time, we didn't have a real module system in JavaScript with like imports or require. This is what we did. Like, we just put a script tag in our web page, loading some external library that added some global that we could just access as if it was like JavaScript built in. Like, who didn't do this with jQuery or with something else? And well, that worked. Except that web apps started getting more complex. And after a bunch of years, in 2009, we somehow realized that that was not enough anymore. And specifically, people working on JavaScript on the server started having big and complex applications with a lot of different files interacting together. And they needed a way to organize all these files, to avoid conflict in the global scope, and to just easily load all the dependencies they needed. And they formed a group, and they defined something that is now known as CommonJS. It was originally called Server.js because, well, it was for the server. And CommonJS, like the first popular module system for JavaScript, has this require function. I'm sure some of you know what this is. This require function to load some dependencies and then an exports object where we can assign values that we want to export from a file, and all modules are self-contained. We don't install globals anymore. And under the hood, this is just wrapped in a function that provides this required exports. You don't have to worry about this. You just write your module, and then something else, maybe Node.js or Webpack, will wrap your code in this function to execute it, providing the correct variables. And CommonJS was great. It's been working well for the past 15 years. And not everybody knows this, but CommonJS is not just about modules. When they decided to build this, CommonJS was a definition of a set of many modules and built-in APIs for server-side environments to make sure that all of them were aligned. This is similar to what's happening now with all the server-side runtimes, such as Node, Dino, or like Cloudflare Workers or anything else, are trying to align on using web standards so that you can write code for one runtime and it should work everywhere. And people were already working on this 15 years ago. And what is now known as CommonJS was just the CommonJS modules subset. CommonJS had a problem. Well, it was called Server.js. It worked on the server because it was all synchronous. And for browsers, this is not really good because you need to go through like HTTP requests to load your files, and that needs to be asynchronous because you don't want to block your UI while loading dependencies. So this group working on CommonJS started working on something else called modules/asynchronous definition, which is now better known as AMD. And it allowed pre-declaring all your dependencies so that the module loader, whatever that was, could first download all the dependencies. And then you had this function similar to CommonJS that could execute your runtime code after everything was already loaded. And AMD also supported asynchronous loading some specific dependencies dynamically because not everything can always be statically declared. And it had other features that CommonJS didn't necessarily have, such as plugins. You could define like this. You can see this text hashbang syntax that's been also like copied by Webpack, for example, to customize how modules are loaded and like what is their behavior. And after 5 years, we finally had a spec for ECMAScript modules. So for a module system built into JavaScript without someone else having to come up with their own idea of what a module is. And we have this export keyword, this import keyword for importing other dependencies. And ECMAScript modules took inspirations from the previous module system, even like they reinvented some things, they did something differently. One of the most important things about it is that it's statically analyzable. So exactly like in AMD, the browser can preload all the dependencies asynchronously, and then after everything's loaded, it can synchronously execute your code. And however, ECMAScript modules or ESM do not need all their wrapper function to declare dependencies somewhere else and then use them in another place. So it's more similar to CommonJS in this, as in you just have a single line of code for each dependency that you care about. And it had something different from these two systems, such as support for both named and default exports. In AMD and CommonJS, you can use either one or the other, not both at the same time. And it took a long time to come up with this ECMAScript module spec. People in 1999 were thinking, OK, we need to standardize within the JavaScript standard some way of loading modules. And they've gone through many different possible design alternatives. Oh, look at this example on the left, because we will see something similar at the end of the slides. And this was from 13 years ago. And many different possible modules implementations. And a couple of years later, in 2019, we finally had, again, in ESM, a way to dynamically load some modules. CommonJS and AMD both provided this. In CommonJS, it was synchronous. In AMD, it was asynchronous. ESM was missing this capability. And so since 2019, we can use dynamic import that asynchronous load the module, returns a promise, and since a couple of years later, we can also use top-level await to avoid having to think about how promises work. And this is where we are now. So now we have a functioning module system that has different features, different advantages, but it's still something is not there. And ESM are good enough that they are used in production applications, and however, people are still writing CommonJS and AMD, and there is no clear migration path from one to the other yet. For example, CommonJS supported lazily loading some dependencies. So let's say that this module that just exports pi is very heavy to execute. And so you only want to execute it when you actually need to run that code. With CommonJS, you could easily move your require call from the top level to something else, to lazily import modules. And with ES modules, it's not possible to do this synchronously. Or other examples are that AMD supports writing multiple modules in a single file. So a bundler would just have to concatenate all your AMD modules, and then it would just work. While with ESM, you cannot just concatenate modules because you have to take care of all the variables that might conflict in different files and make sure that all your namespace imports will work. So it's very complex to build a JavaScript bundle nowadays. And AMD supported plugins, and ESM has nothing like that, at least not something that works across all the places where you can run JavaScript. And also, ESM doesn't really integrate with other module systems, with other languages, such as JSON, WebAssembly. There are ways to make it work. They're just not as good as it was with, for example, CommonJS. And all of these problems, missing functionalities, bring us to what we call modules harmony. We is the TC39, the JavaScript Standard Committee. It's basically a group of people that discusses a lot and works on new JavaScript features through something that we call proposals. And these proposals go through a process with different stages, from just an idea to having the feature implemented in the browser. And modules harmony is a big effort with a lot of features, a lot of proposals, and we've basically been talking about this for months. In every single meeting that this group has, there is some discussion about modules, about how we want modules to be in the future, analyzing how all of these concepts fit together, and how all these proposals depend on each other, how if they're compatible, if there is some differences to proposals that should not be there. And so what is concretely this module harmony? What are the proposals that are being worked on? So how does the future like? Maybe, because until something is a proposal, there is no guarantee that it will become part of the language. Maybe we just realized it's a very bad idea and we should completely ignore that. Or maybe we realize that we know that it's a good idea, but the solution, the exact shape of the solution is just wrong. So we will need to completely change our path. So the slides I'm going to show now are what it's being worked on right now. It might be very different from what we'll have in browsers one day. I'm going to show 6 different proposals. You don't need to read all the names now. I'm going through all of them more in detail. So the first one of those is called import attributes. It's at stage 3. I mentioned there are different stages in the standardization process. Stage 3 means that it's almost ready and that browsers are implementing the proposal now, so that it will be hopefully be available soon. Import attributes are basically some parameters for the module loader. So for whatever is inside your browsers or inside Node.js that, like, given a file path, gives you an executable file, an executable module. So if, for example, a developer wants to load, let's say a developer wants to load a JavaScript file, it will write this import, and then the JavaScript engine, the JavaScript engine will somehow ask to load the file that the developer asked for. And in the next few slides, I will have this division with JavaScript engine on one side and browsers, or rather runtimes, on the other side. The reason I'm having this division is because the JavaScript engine is something that works the same everywhere. So whether it's in browsers, in Dino, in Node, JavaScript has some base semantics that are like standard. And JavaScript doesn't support I/O by itself. It has to delegate to some like platform-specific API. So in browsers, you might have fetch. In Node, you might have some file system API. So I'm keeping this division to point what works the same everywhere and what might be different somewhere else. So the JavaScript engine will ask to the runtime to load some model, and the runtime will then ask to a server, for example, or to the file system, please load this script using this URL that I know corresponds to that Math.js module. And then the server will reply with some content, with some text that has a MIME type, at least on the web, such as application JavaScript. And then whatever the runtime is, will give back this result to the JavaScript engine, telling, hey, JavaScript, I've got this file. In order to execute it, you need to run some, like, these steps. And it has these exports and this metadata. But what if, for example, we want to load a CSS module, like a CSS file inside the JavaScript module system? So using the modules API that we already know? Well, the JavaScript engine by itself doesn't know about all the languages. JavaScript is JavaScript, and then there are, for example, browsers that also know what CSS is. So import attributes are a way for the developer to define some parameters, such as the expected type of the module, that the JavaScript engine will just forward to the underlying runtime. So now the browser knows what CSS is, and it will ask to the server for a style sheet. This is done through like some HTTP headers. Like this is just an example of how import attributes can affect what a module, like how to load a module. And the server will give back some contents. The browser know what it means to execute JavaScript, and will give to the JavaScript engine some steps that the JavaScript engine can understand to execute that CSS code. You might have already seen something very similar. Until a couple of months ago, this proposal was called import assertions, and it was already supported in some tools. While implementing this proposal in browsers, we found that what the web needed was not assertions, but something more powerful to actually affect how module is loaded. So if you've ever seen the first syntax in the slide, just forget about it. Pretend it never existed and only look at the second syntax. Okay, so the second of the 6 proposals I want to show, it's called source phase imports. And before seeing what the proposal is, we need to first understand how modules are loaded in JavaScript. So assume you have a file, like this main.js module, that imports a different module. And this main.js file has some context, such as a global environment, where you can find all your global variables, and it has a base URL that is used to resolve all of its dependencies. The first step when importing a dependency is to get the full URL of the dependency, so to resolve the requested file. Then we need to fetch or compile the file, depending on the language that we are importing. Then we need to attach some context so that this module can then be executed. So it needs a global environment, a global this object to look up all the globals. It needs its own base URL so that its transitive dependencies can be loaded again. And then we link all the dependencies by repeating this process for like all the modules in our dependencies graph. And finally, we can execute all of them in the correct order. And when we import a JavaScript module or a module of a different language that works within JavaScript, the browsers or someone else will run all of these steps. What this proposal does, source phase imports, is to expose modules at an earlier step in this process. For this proposal specifically gives us a representation of the source of a module. So something whose URL has been resolved, that has been fetched and compiled, but it has not been linked and evaluated yet. And you might be wondering, why would I need this? And the main use case for this proposal is to make it easier to use WASM modules within JavaScript. So right now, to use WASM, you need to manually resolve the module URL. You need to fetch and compile your WASM module. Using this, and then you need to manually link, providing all the dependencies. Using this proposal, you will be able to load the source of a WASM module, which corresponds to the compiled WebAssembly.module object, and then only worry about the linking part. And you need to manually link WebAssembly modules because WebAssembly, everything can be compiled to WebAssembly. Not necessarily something knows how the web works, how URLs work. So you usually need to have some manual steps to properly provide all the dependencies. And that's why this proposal doesn't take care of all the import process. And the third proposal that TC39 is working on to solve another missing functionality that ESM has is called deferred import evaluation. This is stage 1, which is the earlier stage, which means that this is something that we're exploring. It's almost certain that the final solution will be different from what I'm going to show now. I've showed many slides ago that CommonJS supports require not at the top level, so that you can lazily require your dependencies only when you actually need them. For example, to save on startup costs for your application. And ESM doesn't really support this. We might be tempted to just rewrite this require call to a dynamic import, since, well, what we want to do here is to dynamically load a module. Except that dynamic import needs a wait, so our function needs to be asynchronous, and async await is viral, and every function that calls our circ function will need to add a wait itself, and suddenly all of our application has become asynchronous with all these async await ticks in places. And that's annoying. You just want to do some very minor refactor, and you have to refactor the whole code base. So what if we exposed modules at a different step in this loading pipeline? So the problem in browsers, the reason require doesn't work in browsers is because module loading needs to be asynchronous. So what if we first load all the modules and load of our dependencies and just avoid evaluating it? Yes, it's not as good as CommonJS, as the lazy requiring CommonJS, because we still need to do some work. But we can save maybe half of the cost of loading a module. And this is where the deferred import evaluation proposal helps. It gives us a module that only needs to be evaluated and nothing else, so that we can lazily evaluate it when we actually need it. And in this example, this import defer will load the module, and then the module computed by is only executed in this once the circ function will access the mod.py export. And third or fourth, I've missed the numbering, proposal I'm going to show is this proposal doesn't even have a name. I'm going to call it custom module loading. Depending on where you read, you could find a different name. Because, well, again, it's stage 1. It's an idea we're working on. It's a problem we want to solve and not a solution yet. So I've shown this process of how the JavaScript engine asks to the browser or to the server runtime to load some file. That browser will take care of actually loading that file, performing some I/O operations, and then give the result back to the JavaScript engine so that it can execute it. And we've also seen this loading pipeline. And I've now marked this with JavaScript engine at the bottom and the various runtimes at the top, just to map better these two different ways of visualizing how modules are loaded. So the JavaScript engine takes care of linking everything together, and it only delegates to the underlying runtime for loading all the modules individually. And wouldn't it be nice if we can hook in this let's load a module process? Like we've done this many times with our bundlers. Like Webpack has plugins to support custom module types, and the same for Rollup. And in Node.js, we can have some hooks, some require hooks to change how module is loaded. And even in browsers, we can use service workers to intercept the loading process and transform a module, give back a different module with some custom logic that we can write. So, like for example, when you use a service worker, the logic to load a file is intercepted by the service worker. So if the browser asks to someone, which is not the server anymore, to load some file, we can see, oh, the browser wants this file, so I'm going to load this file this way from the server. Then, for example, the server might reply back with something different from JavaScript, such as a TypeScript file. Our service worker can, like, this is again an example, compile the file on the fly from TypeScript to JavaScript and give back the JavaScript file to the browser, pretending that nothing happened, pretending that the file was JavaScript since the beginning. And like browsers don't need to know what TypeScript is if there is some custom code that we wrote to properly transform TypeScript to JavaScript. And this is equivalent to hooking into the fetch compile phase, because it's like we intercept the resolved URL from the browser and we give back a compile module. Node.js is something similar, like I mentioned with require. It also has something similar with ESM. There is a flag called experimental loader that allows us hooking into the module resolution process. So when Node sees an import statement, instead of just transforming that import statement to a full path to an URL, it will ask to our experimental loader to resolve that like string that we put in the import statement to the file path, and then we give it back to Node. And then Node also supports hooking into the loading process. So our loader could get the file URL, load the file from disk, come from web server, do whatever transformation it wants, and then give it back to Node so that Node can execute that file that's been, like whose loading process has been hooked into. And this is equivalent to hooking to the resolve and fetch and compile phase that I showed before. So what this proposal does is to try to analyze how all the different runtimes are solving the same problem in different ways, and try to provide a unique way to doing this. So with this proposal, when JavaScript wants to add a module, we could have what this proposal calls an import hook. The import hook receives what we call the specifier, which is the name of the module, basically, so mat.js. And this import hook can have some custom logic that you can write to have your own module loader to resolve your URL, to then fetch URL, and return a module linked together with its execution context and with like hooks to load its dependencies and all the info that a module might need to be executed. And this is done by making modules not something just, oh, a file is a module, by making modules real JavaScript objects. So something you can have handle on, you can pass then a module around, similar to what you can do with functions. Functions, not just syntax, functions, something that, well, you can pass around. And we can see that this is equivalent in hooking into these three phases, resolve, fetch and compile, and attach context, that are exactly the phases that are usually handled by the browser, by Node.js. So with this proposal, we could, for example, take some modules that know how to resolve themselves in Node and re-implement the node resolution in the browser, or vice versa. And we can more easily move code from one platform to the other by virtualizing how the module loader works. And we've just seen that now modules would be a thing we can store in a variable. And how do we create modules? Just with the module constructor? I've mentioned functions, and we have syntax for functions. Like, sure, functions have the function constructor. We can pass some code to this function constructor to evaluate this code. But like, evaluating code for strings is bad. Like, our editor would not properly syntax highlight that code, and we should be careful to not evaluate like strings coming from untrusted parties because they might have some like security attacks. And the same applies to models. We do not want to just store a string in our module and then execute it. So exactly how functions have an expression syntax we can use to create a function. Modules have the same. With these proposals, modules would have the same. So we can declare inline modules that can be later executed. Like to execute a function, we call the function. To execute a module, we just import the module. And we can execute the module wherever we want. So we could, for example, have some inline modules define a file, pass them to a service worker and to a worker, and execute them in a different worker to have a multi-thread application. Or we could just have some behavior that we want to pass through some other library. And we want this to be completely self-contained without capturing standard variables and like serializable. So like there might be difference between these and functions. And then functions have a declaration form instead of an expression form. So instead of assigning a function to a variable, we can just say, oh, I just see my timer is at 0, 1 minute and I'm done, I promise. And so can we do something similar for models? And this is where a sixth proposal helps us, module declarations. That, well, gives us static syntax for declaring modules inline in a like statically analyzable way. And why is this proposal good? Why does this proposal help us? Many slides ago, we saw that AMD had a difference with ECMAScript modules. AMD allowed very easily bundling modules in a single file by just like concatenating all the files together without worrying about scope resolution and about without having to implement in our bundler all the basic semantics of ESM. And with module declarations, we can do the same. We can have multiple modules just concatenated in a single file. They can import each other. So yes, bundlers still need to make sure that all the imports refer to the correct module, but they don't have to re-implement ECMAScript modules from scratch. So writing a bundler would become something much simpler, something that like anyone could try doing. And that's it. That's 6 proposals that maybe we will see one day. When? Or maybe the question is, will we see them one day? Like, again, they're proposals. Some of them will be in browsers maybe at the end of this year. Others will need multiple years, maybe 5 years, or we will be lucky in 2 years. I'm sure that ECMAScript models will change and will improve and will be much easier to use them. We just don't know when this will happen, how exactly this will happen. And yeah, that's it. Thanks for listening.